planets will revolve around the sun in a particular elliptical orbit, and the sun is present at any one of the focii. Any one of the focii means, what do you mean by any one of the focii? Anybody can tell me? What do you mean by any one of the focii? Maybe the sun is present at F1, or maybe sun is present at what? Maybe sun is present at F2. So that is only ways to called as Kepler's first law of planetary motion, or we can call it as what? Or what we can call it, guys?
Law of orbits.
Law of orbits. So maybe the sun is present here, or maybe the sun is present in the F1, but the planets are revolving around the sun. So that is only called as Kepler's first law of motion, or we can say Kepler's law of planetary motion. Any doubt, anybody? I understand. Divya, no response at all. Mr. Gokul, Arun Kailash, Harini, nothing responding.
Yes, sir.
That is what. So please, all of you write it the definition. Maybe that is what. See, that is why I drawn you two diagrams also now. Maybe the sun is present at F1, or maybe the sun is present at F2. Doesn't matter. So any one of the focii the sun is existed is only known as Kepler's first law of planetary motion, or we can say also, what is another name? Law of orbits. Okay. Law of orbits. See that single definition, how much time it has been taken to us to explain. Everything we have to know. That is why. So please write the definition. Have you understand?
Sir.
Have you understand? Ready? Is it okay, Hari?
Found out, sir.
Yeah, Hari. Ask.
Sir, in heliocentric theory, they said sun is in the center, no, sir. Then that theory also wrong, sir.
That theory is not wrong. It is right, but they said that it will be in a constant circle, but it is not the circle. It is an elliptical shape.
They said that sun is in the center, right, sir?
Sun is in the center. We are accepting that theory is true, but it is not in the circular path. I understand.
Okay, sir.
It is not in the circular path. Understand, Hari, what I am saying?
Yes, sir.
Yeah, that is what you have to. Okay, wa? Yes? Yes, please. I understand, Mitaksri. Any doubt, Mitaksri?
No doubt, sir.
Now, have you noticed here one thing? When a planet is in circular path, always the distance between the planet and the sun is same. Is it right or wrong? Is it right or wrong?
Yes.
But if it comes to the elliptical orbit, is it the length of the shorter line joining the planet and the sun is not constant throughout the elliptical path? Is it right or wrong? Is
Yes,
it right
sir.
or wrong? Yes or no? Because it is an elliptical path. Sometimes the planet will come closer to the sun. Sometimes the planet will move far away from the sun. That is what the difference between when the planet is revolving around the circular path, when the same planet is revolving in the elliptical path. Are you understand, everybody? Please respond. Have you understand? So please write first. First, Kepler's first law of planetary motion, right? According to the Kepler's first law of planetary motion, according to the Kepler's first law of planetary motion, according to the Kepler's first law of planetary motion, comma, all the planets revolve around the sun. All the planets revolve around the sun. All the planets revolve around the sun in different elliptical orbits. In different elliptical orbits. In different elliptical orbits. In different elliptical orbits, and the sun is located at, where the sun is located, Mr. Johan? Where the sun is located? No response. Where the sun is located, guys?
There are F1 or F2, sir.
Any one of the foci of the orbits, right? Orbits, and the sun is located at, and the sun is located at, and the sun is located at one of the foci of the orbits. One of the foci of the orbits. One of the foci of the orbits. Have you understand? One of the foci of the orbits. This lie is also known as, this lie is also known as, this lie is also known as the, what is to call? This lie is also known as the law of orbits. Law of what, guys?
Orbit.
Law of orbits. Is it okay, everybody? Yes? Now, before going to study the second law, you should understand when the planet is moving, sometimes it will move closer to the sun and sometimes it will move what? Far away from the sun. Understand? So the line joining from the sun and the planet is always is not the same. Is it yes or no, guys? Sometimes it is maybe shorter, sometimes it may be very, very longer. So that is what, with the help of that only, we are going to derive the second law, Kepler's second law of planetary motion. Hope you all understand the Kepler's first law. Is it any doubt? Anybody please ask me. Are you clear, guys? So simple. What do you mean by first law? Means sun is located at any one of the foci. Planets are revolve around the sun. That's all. Are you understand, Harini? All the planets move around the sun and it's an elliptical orbit. With the sun is located at one of its foci. That is only called as Kepler's first law. Is it okay, guys? Kaushik, Harish, Gokul, that is what is called as Kepler's first law of planetary motion. Also, we can call it as law of orbits. Now, all of you keep heading. Kepler's second law of planetary motion. Kepler's second law of planetary motion. Also, we can call it as law of areas. What is to call, guys? Law of areas. Okay, so now law of areas, we'll study in the tomorrow's class, but as I told you, one point you should know. That is what, please write. After that we'll wind up. Right. While a planet revolve around the sun, 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 in its elliptical orbit, 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 the length of the shortest line, the length of the shortest line, the length of the shortest line, the length of the shortest line joining the planet and the sun, the length of the shortest line joining the planet and the sun is not constant throughout the elliptical path. Is not constant throughout the elliptical path. Is not constant throughout the elliptical path. Is it right or wrong, guys? Is it right or wrong?
Yes, sir.
Yes. Now look into this picture. Can you able to see my screen, Hari? Yes, Akilan, Arun Kailash. Now suppose, let me imagine here is the sun now. If I join a line to sun and the planet, Now the planet will come here. If I'll join a line, if the planet is here, if I'll join a line, is it the length is same every time? The path length is same? Is the path
Yes, sir.
same? Yes, please respond, guys.
No, sir.
No, that is only the point which you have written now. The path joining the line between the planet and the sun is not constant. Is it okay, Akilan? With the help of this only, we people are going to study the Kepler's second law of planetary motion, known as law of areas, which we will study in the next class. Hope everybody understand what is law of orbits. Is it right or wrong? At least respond in chat if you are not able to speak. Yes, please.
Yes, sir.
Okay. So, Mr. Harish Jairas, have you understand?
Yes, sir, very clearly. Sir.
Yeah. Okay. Have you written the notes? Please make the notes, as it is very concern for me. Okay. So
Yes,
you have
sir.
to maintain proper notes, everything regularly and write it. Kaushik, have you understand, Kaushik? You? Mitakshri? Harini?
Yes,
Yes,
sir.
sir. Yes, sir.
About Kepler's first law. Okay. So we'll proceed with the second law and third law in tomorrow's class. Third law, it is very important as well as second law. So because as it is numericals also, we have to solve. So with this, I'll stop. Let it be. So thank you, everybody. And Divya, I don't know. Divya is not responding. So okay, Mitakshri, ask Divya either she is able to understand or not. So okay, thank you. Thank you, everybody. We'll meet in the next class.